Alright, in this video we're going to be looking at some algorithms for whole number addition and subtraction. What we'll look at in this video is just the addition, subtraction, and the equal add-ins algorithm. Those three algorithms we'll be looking at when we're dealing with whole number addition and subtraction. Okay, children use their understanding of addition to develop quick recall of basic addition facts and related subtraction facts. They solve arithmetic problems by applying their understanding of models of addition and subtraction, such as combining or separating sets or using number lines, relationships and properties of number, such as place value, and properties of addition, commutativity, and associativity. Also, children develop, discuss, and use efficient, accurate, and generalizable methods to add and subtract multi-digit whole numbers. They select and apply appropriate methods to estimate sums and differences or calculate them mentally, depending on the context and numbers involved. They also develop fluency with efficient procedures, including standard algorithms for adding and subtracting whole numbers, understand why the procedures work on the basis of place value and properties of operations, and use them to solve problems. Okay, let's look at the concrete model of adding algorithms. Here we have 14 plus 23. A concrete model is just using the base 10 blocks here. In this case here, 14 can be represented by one long and 4 unit cubes. 23 would be 2 longs and 3 unit cubes. If we combine these two together, we'll get 3 longs, and 7 unit cubes. That represents the number 37. So here 14 plus 23 gives you 37. Okay, so this is what the concrete model looks like using base 10 blocks. The expanded algorithm is this. If we have 14 plus 23, we add the ones. That's 4 plus 3, that's going to give you 7. Then you add the tens, 1 plus 2, or 10 plus 20, that will give you 30. So 30 plus 7 will give you 37. And the traditional standard algorithm, of course, is just simply adding the ones column and the tens column. 4 plus 3, that gives you 7. 1 plus 2 gives you 3. Which is the one that I'm sure that most of your students use when they add whole numbers. Now, let's expand the algorithm with regrouping. Let's say 37 plus 28 is what we're trying to add. We add the ones. 7 plus 8 will give you 15. And then add the tens. 30 plus 20, that's 50. 15 plus 50 will be 65. Okay, so this is the expanded algorithm when you're doing regrouping. And the traditional standard algorithm that has the regrouping is this. You add 7 plus 8, that's going to give you 15. You write down the 5 and you put a 1 on top. Okay, because you got a 10s that you want to add to the 30 and the 20. So we put the 1 there. Now 3 plus 2, that's 5, plus this 1 will give you 6. So in this case here, 37 plus 28 would be 65. Let's look at 2 3-digit numbers that have 2 regroupings. Let's say we have 186 plus 127. If we represent 186, you're going to have 1 flat, 1, 2, 3, 4, 5, 6, 7, 8 longs, and 6 unit cubes. 127 is represented by 1 flat, 2 longs, and 7 unit cubes. Okay, now we got 6 ones and 7 ones. That's going to be 13 ones. We're going to regroup that as 1 10 and 3 ones, because I can take 10 of those unit cubes and trade that in for one long. Okay, so that's like writing down the 3 and putting the 1 on top. Okay, and this does continue. Now in this case here, we're going to add the 10s and then do a little regrouping. Now, we know we got 11 10s because we got 1 10 and then 8 more 10s. That's going to be 11, 1 10, 8 10s, and 2 10s. I'm sorry. That's going to be 11 10s. So all of this is 11 10s. Regroup this by trading 10 of these longs for 1 flat. Okay, so 10 longs make up a flat. And that's the same as writing down the 1 and carrying the 1 in the hundreds place. Or regrouping the 1s. And then you're going to add your hundreds. So that means you have 3 flats. So that means that's 300. So this representation with the fewest number of base 10 blocks will be 313. So that represents 186 plus 127, which is 313. So as you can see here, this is how this is as you can see, this is done using a concrete model and how it's related to the standard algorithm. Okay, left to right algorithm for addition. If we have 586 plus 568 plus 757, we go from left to right. In other words, 500 plus 700, that's 1200. 60 plus 50, that's 110. 8 plus 7, that's 15. We're going to add these partial products. 1200, 110, and 115. Add those together, you'll get 1,325. Okay. And in this case, if they showed this in a shorter way, 8 plus 7 is 15, of course. And then you have 6 plus 5, that's 11, but you have 1, that's going to be a 2. 5 plus 7 is 12, but you had to add 1 to that. That will give you a 3 here. So this will be 1325, or 1,325. Another algorithm is the lattice algorithm for addition. And here's how this works. Let's say 3,567 plus 5,678. You're going to do 4 boxes because we're adding 2 4-digit numbers. And notice that we're going to put diagonals here. We're going to separate those boxes into triangles by drawing diagonals here. And then we're going to add each column one by one. We put the 10s number in the top and the 1s number in the bottom. Okay? If the sum adds up to only one number, then the 10s will be a 0 here. Like 3 plus 5, that's 8. Okay, so we put a 0 here and the 8 there. 5 plus 6 is 11. So the 1 would go here and the 1 would go down here. 6 plus 7 is 13. So the 1s, which is your 10s, that goes here. The 3, which is your 1s, goes down here. Then 7 plus 8 is 15. So the 1 goes here and the 5 here. Now to get the final answer, we add along the diagonals. Okay? So here we can't add anything to the 5, so we bring down the 5. Add the 3 and the 1, that will give you the 4. Add 1 and 1, that's going to give you 2. And then add 8 and 1, that's going to give you the 9. So 3,567 plus 5,678 will give you 9,245. Okay, this is a good way of showing students how to add using the lattice method for addition. And also we have the scratch algorithm for addition. What's going to happen is this. You're going to add the numbers in the units place starting at the top. When that sum is 10 or more, record that sum by scratching a line through the last digit added and writing the number of units next to the scratched digit. Like in this case here, 87 plus 65 plus 49. We add 7 plus 5, that gives us 12. is more than 10, so we scratch the 5 out and put a 2 here. Okay, and this continues here. And we're going to continue adding units, including any new digits written down. When the addition again results in a sum of 10 or more, repeat the process. Okay. And as you can see here, 2 plus this 9 will give you 11, so we scratch the 9 and put a 1 here. And when the first column of additions is completed, write the number of units, which is the 1, below the addition line in the proper place value position. Count the number of scratches. In this case here we got 2 scratches, so we're going to put the 2 in this column right here. Because then we're going to add these together, and then whatever 8, 6, and 4 come out to be, we add the 2 to it. And then we repeat the procedure for each successive column until the last column with non-zero values. At this stage, to sum the scratches and sum the scratches up and then place the number to the left of that current value. In this case here, this 2 plus that 8 gave me 10. So we scratch the 8 and put a 0 there. 0 plus 6, that's 6. 6 plus 4 is 10. We scratch the 4, put a 0 here. Here we got 2 scratches, so that 2 will go in front of the 0. So 87 plus 65 plus 49 will give us the final answer of 201 using the scratch algorithm for addition. Now let's look at some algorithms for subtraction. Okay, now let's look at a concrete model for this situation. 243 minus 81. Now we represent the 243 with 2 flats, 4 longs, and 3 units, as shown. So we want to subtract 61 from 243. We try to remove 6 longs and 1 unit from the block shown in the figure. Now we can remove 1 unit, but we need to remove 6 units by trading 1 flat for 10 longs. So one of these flats will have to be traded for 10 longs in order to subtract 61, or remove 6 longs in this case. So here's the rest of this. This 1 flat was traded for 10 longs, as you can see. Now we can take away 1 unit and also the 6 longs, which will leave us 1 flat, 8 longs, and 2 cubes, 2 units, or 182. So we can say here 243 minus 61 will give us 182 as our final answer. And that's using a concrete method. Okay, and that's just what I just mentioned here, as you can see. All right, let's look at the equal add-ins algorithm. Equal add-ins. The equal additions algorithm for subtraction is based on the fact that the difference between 2 numbers does not change if we add the same amount to both numbers. In this case here, if we want to do 265 minus 163, what I can do here, we can start by trying to make this a friendly 10, get a 0 in the tens place by adding 7 to this number and to both of those numbers here in this case. 255 plus 7 is 262. 163 plus 7 is 170. So that's 262 minus 170. Okay, now I can extend this by adding 30. Because if I want to make this 170, 200, I can add 30 to the 170 and add 30 to the 262. So I'm doing equal additions here. 262 plus 30 will be 292. 170 plus 30 will be 200. So 292 minus 200, that's simply 92. So we can conclude 255 minus 163 would give us 92 using the equal add-ins method. Okay, so that would conclude this particular video on the algorithms for whole number addition and subtraction.